Hi team, so our big question today is how do computers use algorithms to sort and search for data? Basically, how are we using simple instructions to sort through data or search for data? Well, previously we've learned that we can search through data in two different ways. We can use the linear search, which is great for when our list isn't in order. But it does take a very long time because we're searching the first item, then the second one, then the third one, and up in order, right? Now, the binary search we found to be, well, just way faster. The problem is with a binary search, the data has to be in a certain order, whether it's chronological or numerical or alphabetical. It needs to be from the smallest to the largest so it knows where it needs to go after each search. Last week, we talked about how the bubble sort is a really simple but really slow algorithm to use. It helps us to sort data, but we have to take multiple passes through that data to have it sorted. Today, we're going to look at the insertion sort, and the insertion sort is much, much faster. Let's imagine this for a second, that we've got a bookshelf with books from all of these authors up on it there. I'm hoping that you will notice that each one of those books has been put in alphabetical order by the author's surname. Now let's imagine that we've got a book by George Orwell to add to our bookshelf. Well, where would you put it? Well, you'd make space where it belongs between Roald Dahl and Patrick Rothfuss and insert that new book there. This is essentially how an insertion sort works. All you are going to do is take two parts, a sorted sublist and an unsorted sublist. And with each pass through the list, an item from the unsorted sublist is compared to the items in the sorted sublist until it is inserted into the correct position. That is a fancy way of saying that all you're going to do is you're going to take the first number as your sorted list. The rest of it is currently unsorted. So let's imagine that we've got 43 as our sorted list, 21 is our first unsorted item, and we just put it where it belongs. So now we've got two things sorted and four unsorted. Then we take the next number and put that where it belongs, and now we've got three sorted and three unsorted. You notice how as we go through this list, the sorted list becomes larger and the unsorted list becomes smaller, until you're left with just one at the end. You put that number in the correct position, for this one in between 21 and 43, and there you go. After just one pass through this list, from the first number to the last, my list is now in order.